Hey guys, in this video I'm going to talk a bit more about the early Motorola electrostatic sets. I did a video a while ago and I showed off my collection, showed one of these playing, and gave a really brief overview of how they work. I want to go into a little more detail in this video with some specific tips on how to restore the trickier aspects, which are the ballast tube, the high voltage circuitry, the high voltage caps, and so on. I also want to try to fix the mask on my suitcase set down there. So what I've got out here are three representative sets of this family. Down here we've got the suitcase set. Literally you carry it around like a suitcase and the top pops open and you can watch TV and I guess take it with you on a trip. This is the most common, the mahogany VT71. And this is the last of the line. This is actually an 8-inch set, whereas the other two are 7-inch sets. And it's a nice big light cabinet. I know a couple of my YouTube friends have these sets, and I'm hoping to impart what knowledge I have to help them with their restorations. And anybody else out there who might be working on one of these. They are fairly popular, I think because word has spread that they are fairly easy to work on as far as TVs go and a good starter set, and they're also fairly common and plentiful. And as far as vintage TVs go, they're fairly small and fairly light. And one of the reasons they're so light is because this, I won't say they're cheap sets, but they sure use some clever engineering to get the parts count down and make these inexpensive. They were the first TVs to sell for less than $200. But once properly restored and tuned up, they do work quite well. So if you get your hands on one of these sets, first thing you want to do is figure out what exact chassis you've got. There are a lot of revisions of these. Most use the TS4 and then there's usually a letter after that. But there's also a TS18, which is what that guy uses. I don't know why they went from TS4 to TS18 because it's just the next step in that family. So what I've got out here is what they call Wallace Telliade. It's a compendium of schematics. This particular one starts out with the TS4B. There wasn't a TS4A, but there is just a plain TS4, which is what's in this set. However, there are numerous variations of the TS4, including this one, which is so early there is no accurate service info on it. So they must have gotten to the point where they made enough tweaking to the TS4 that they figured we better start putting some letters after these to differentiate them. So we've got the TS4B, we have the TS4C, the TS4D, and so on. The E, the F, the H, but there is no I. I imagine they avoided the TS4I because it might be confused for a 1 and look like a TS41. But even with the J, there's a TS4J early and there's a TS4J late, and I'll go a step further and say there's a TS4J late, because this set has a TS4J in it. It's not the same as what's shown on here. So, you cannot be too careful with correctly matching up your set with a schematic. Some of the obvious things to look for is a tube lineup. For example, the really early sets like this one use a Lochtel tube, a 7F8 for the converter. The later sets, I'll use a 12AT7. It's a little 9-pin miniature tube. Another thing to look for is the contrast control on the really early sets. It's just a potentiometer, nothing fancy. Just signal on one side, ground on the other, and the signal comes out. Later sets, there's the contrast control. They put a whole mess of capacitors on it and it's tapped in several positions. All this was to help with an issue with the contrast where well, if you ever watch an old black and white TV when there's a lot of heavy contrast, like white lettering along the bottom on a black background, it can get smeared and cause noise in the audio and so on. Well, this network was meant to help that out a little bit. The TS18 also has this type of network on the contrast control. The lower the letter, or no letter, means it's older and rarer. By far and away, the TS4Js are the most common. They made far more of these than the other variations. So, let's see, amongst my sets, TS4J, I've got another TS4J, I have a TS4H, I've got TS4, and 2 TS18s. Now I'm going to pop one of these open and give you an idea what they look like inside. This one in particular is a suitcase set. The outside is covered with something I think called Tolex, which is kind of like a heavy-duty wallpaper, fairly common on amplifiers from that time period. This 1/4-inch phono plug on the top is for the antenna, which is, if you're lucky, it comes with that inside the lid of this case. Mine was missing one, but after a couple of years I did find one on eBay. It's got feet on both the bottom and on the back side. So you can set it down like this to watch it, and if you pick it up you can also set it down like this. The feet on mine were rock hard when I got it. I ordered these reproduction feet from Antique Electronics Supply. They have a number of different feet. These turned out to be a really good match. I wouldn't use them on anything with any more weight though, because even this is kind of at the limit because they're a little bit too mushy. So I imagine after time these are going to deform even more, but for the time being they've held up alright. Two latches here, top flips back, and you've got yourself a TV. So there's the antenna, and here's the base for it. So you can either plug this plug into the socket on top of the set, or if you need to move this around somewhere else for reception, you can plug this into this base, which should have like a 3 or 4 foot long piece of twin lead coming out. You can position this wherever you like, and you hook up these terminals to the back of the set. It's supposed to be locked in under this flap here, but mine's gotten torn and brittle with age. And here's the set. And here's the screen. So unlike these sets, which are quite rectangular, this set, I wouldn't quite call it a porthole, but it's getting there. So a little bit of trim on the top and bottom. Now what I want to do this set in particular is brace up this picture tube. As you can see, it's just flopping around inside there. You got this huge void up here. Should be pushed up nice and snug to the face. The masks that come with these are almost always hardened and rotted away. You can buy reproduction masks for these sets, like this is a reproduction. A little pricey, but it's fairly important to support this CRT because it's only supported by this mask at the front and then a clamp in the back on the neck, nothing else. So this set right now, the mask is gone and it's only being held on loosely by the neck, so it's very dangerous. It could snap off. The coating on my cabinet's in decent shape, although there's some gouges here and there. You can buy Tolex, again from Antique Electronics Supply. And I have seen it done, not on these but on amplifiers. It's a fair bit of work. You need to get all this off, which is about as much fun as stripping off old wallpaper from walls. Then you have to scrape off the old adhesive. You have to carefully prepare your new pieces, use some contact cement and glue them down. But with some time and patience, I would imagine it would look really nice if you could manage to do it. In order to take one of these suitcase sets apart, you want to take the knobs off, if you're lucky enough to get knobs. There are reproduction brown knobs available, but that's the only color you can get. These, I believe, are original to the set, and it's a nice matched pair. These fine-tuning knobs are especially scarce because they quite often fall off because they're quite small and they're just held on by this knurled shaft. If they get loose, you can take a screwdriver and stick it in between those bits of metal there and spread it apart. These feet do double duty to hold the chassis in place. This one's just on its own, just a screw and a nut on the other side, but the other three I will hold the chassis down. So 1/4 inch nut driver, loosen those up. Now to get the other two out, I'm not going to do it with it in this position, because if I do, the chassis is going to drop down about 1 inch because it's held up a bit off the ground right now by those feet. Take these out, it's going to go boom, hit the ground. So what I'll do is I'll put it up on like a coffee table and hang it off the edge a few inches and then remove these. I got this set off of eBay 2 or 3 years ago for about $100. It was a buy it now and a local pickup, so I went for it. I got lucky and the picture tube was good. However, it's missing the back, the speaker's missing, and all the tubes were gone. Since then, I've repopulated most of the tube sockets, and a speaker, I believe, is on its way to me. I picked up some TV knobs at the last antique radio swap fest in my area. Not knobs that I needed, but knobs that I thought other guys might need, and that was right. I was able to parlay those into a number of other items I've needed. Some knobs I needed, some speakers I needed, and so on. So that worked out quite well. As far as his back goes, I can ask around and maybe somebody's got a junker set I can get a back from them. Otherwise, I could just make one out of masonite or something like that. It's a good idea to have a back, especially on one of these suitcase sets, because they're meant to be carried around and stored with this side facing the ground. So it'd be nice to cover this if possible. So very easy to identify this one. TS-4 right there on the chassis. Just serial number in January 5th, 1949. Now these serial numbers, I've found out from consulting with other guys and comparing them to my sets, are not sequential from the very first one that was made. We think that this number was reset to 0 every month. So in January of 49, they had already made 61,454 of these, just in the first week of 49, which is like the peak production for this set. Because they made millions of these, so there's just no way. And they introduced these in 47. That's when this set is from. So early it's got channel 1 on it. But this is one of the last ones they made. Some of these are copper plated, some are not. I don't know. I think they originally copper plated to go along with their golden view. That was their slogan, And this isn't quite gold, but I suppose it's goldish, especially when it's new. So I'll remove those 2 nuts and let's get this chassis out. After you get the bolts out of the chassis, there's a few other things you have to do. If I had a speaker up there, I would have to pull out 2 connectors going to it. There might also be a ground wire going up somewhere up top. In this case, I don't have one. Looks like the wires have been cut going to the antenna as well. And you have to disconnect the CRT. Be really careful when you do this. These bases can be loose, like this one is. That needs to be re-glued. Also, you can pull the pins right out of the CRT base. It's happened to me once or twice. If it does happen to you, carefully pry them out of this plug and clean them out with some solder wick. Push them back onto the base and solder them back onto that pin. Maybe put a little bit of adhesive around the base, like 2-part epoxy. Don't be too generous with it, because you do have to be able to get this plug back on to make a good electrical connection. So the picture tube will stay in the cabinet when you slide the chassis out. Here's the insides of the cabinet with the chassis out. Quite clean. So it's in good condition. I think I'll put some sealer on it like shellac to protect it even more. But otherwise, you know, no mildew. Really no dirt either. Nice patch of asbestos up there. Oh, something else, yeah. There's a ballast tube that sits back here. It gets really hot. And because of that, pretty much all these sets have a nice patch of asbestos to protect the wood from the heat. If you're going to be using the original ballast or replacement glass ballast, you really want to keep something up there to protect it. I've just been leaving the asbestos in place. As long as you don't start poking at it and ripping it to make it fibrous and airborne, I don't think you have anything to worry about. If you use a different type of ballast such that you're not going to be generating so much heat, then you can go ahead and remove it. Now what I want to do on this particular set is secure this CRT. So we got two problems here. One, this clamp on the neck is loose, really loose. And two, there's nothing supporting it at the front whatsoever. It's supposed to be pushed up further, and then originally there was a big foam gasket that went around there. There is no reproduction made for this type of set. What I'm hoping to do is to take some closed cell foam tubular insulation, like for putting around windows, and try to make a loop of that and get it in there to support this properly. So this is the standard chassis. This is what they look like, regardless of the variation TS4 through TSJ or TS4J. They all look like this. So like I said, some are copper plated, some are bare steel. Really doesn't make much difference, other than the copper affords some protection against corrosion. What's different about this particular one, though, is right here. It says specifically use ballast tube 17A485459. If you look in any of the service info for TS4J, that's not what they say. They say to use a different ballast tube. I don't recall the number off the top of my head, but it ends with 303. And that's what every version uses, the TS4, 4B, 4C, 4D, etc. They all use the 303 ballast tube. Whereas the TS18 and some of the TS4J lates use the 459 ballast tube. We'll get more into that later. Up here we've got the various tuning slugs for the channels in the IF. This is the IF strip here. These are the multi-sectional electrolytics for the power supply. Got vertical oscillator, sync tubes, audio tubes, and this is the horizontal stuff, and this makes the high voltage. I found that the best balance point for these, if you want to put it on its side, is against the high voltage cover. These are secured by a whole bunch of 1/4" sheet metal screws. Usually a bunch are missing. I replaced some of these, but I'm still missing a few. Make sure that's secured down well. Once it is, you can balance it just like so. Not really stable, but stable enough to take a look at it. A suggestion I saw online was to put this down on a big piece of plywood and drive some wood screws down into these two screws. It'll hold it down nice and steady like this, so you can work on it. Otherwise, you can rest it upside down and it will balance on the top of the high voltage and the filter caps. But keep in mind that there is a screw protruding there, and that goes right to the high voltage coil, and you do not want to damage that, because you're not likely to find a replacement for it. So here's the undersides. This one is possibly all original. If there have been any repairs, very, very few. I think virtually all the capacitors are Motorola, like this. Typically the first to go are the high voltage caps, which are down here. You can see there's one Motorola, but this one doesn't seem to have a name on it, so this might be a replacement. Now it may look like somebody did some work in here, but I did that. When I was restoring one of my other sets, Somebody had cannibalized a lot of parts out of it, and I was able to replace them all except for these. These are somewhat specialized ceramic high voltage capacitors, fairly important for the stable operation of this set. So while I was working on that set, I was having trouble getting this section to work right, so I borrowed some parts out of here. Since then I have secured some proper replacements, so eventually we'll get them all sorted out. These sets are electrostatic sets, and what that means is they use an electric field to deflect the electron beam going to the face of the CRT rather than a magnetic field. To do that, they need high voltage both to accelerate the electron beam to the front of the picture tube, just like all TVs do, but there's also a high voltage on those deflection plates, and that's what 4 of these high voltage caps are all about. So the tubes in here develop sawtooth wave for both horizontal to make the beam go left to right and vertical to make the beam go from top to bottom. Those signals need to be coupled into the picture tube, which is running at a potential of around 6,000 volts. Normal tubes can't handle anywhere near that kind of voltage, so they have to decouple the high voltage on the CRT from the lower voltage on the tubes, and that's where all these caps come in. 4 of them, 2 vertical, 2 horizontal, and the 5th one is used to actually filter the high voltage going to the acceleration anode on the picture tube. The most common question I see about these sets is, where do I get these guys? Where can I get replacements? Well, unfortunately there are very few choices. Really these days I have to recommend going to Just Radios in Canada. Allied Electronics used to carry them in both 6, 8, and 10,000 volt flavors, and I like to go with the 8,000s. It gives you a little bit of overhead. These caps are rated at 6,000 and the ones from Just Radios are too, but this set runs at close to 6,000 volts, so you're really right at the upper design limit of these caps. But unfortunately Allied is like on perpetual back order. Occasionally I also see them on some surplus sites like Electronics Gold Mine or surplus sales in Nebraska, maybe on eBay, but as far as reputable places that keep them in stock, Just Radios. That's pretty much the only game in town right now. And they are a little bit expensive, you know. So these were made as inexpensive sets, but as far as restoring them goes, it's actually one of the most expensive sets to restore. Especially if you're going to go and buy a reproduction CRT mask, get a ballast, or recreate a new ballast. You might need a new picture tube, you need these high voltage caps, and so on. It can get quite pricey. So just keep that in mind. You may get one of these sets really cheap, but you're going to be in for well over $100 to get all the parts you're going to need to restore one of these. These controls down here are for focus and centering the picture, and these controls are also at a potential of thousands of volts. So to keep you from zapping yourself, they actually have plastic shafts on them and long plastic extenders to isolate the metal on the potentiometers from you, so that that 1.5 inches or so of plastic is there for your protection. Some of these sets have knobs and some don't on the vertical and horizontal hold. That's really not there to prevent you from getting shocked. It's just as a nice convenience because these are kind of touchy controls, and having a larger knob gives you finer control. When I find sets that don't have these, I just find a knob that's fairly close and put them on here. Makes it much nicer to work on these. The rest of the caps are fairly conventional. They're just, you know, like 0.05, 600 volts, one of the most common caps you see in TVs. 10 microfarad, 50 volt electrolytic. You shouldn't have much trouble getting the rest of these. This does not use a transformer, runs right off the AC line, and there's a voltage doubler, which is what these 2 selenium rectifiers are for. Replace these with a couple 1N4007 diodes. And I've done it both with and without series dropping resistors. These selenium rectifiers are not as efficient as silicon diodes. They do have some resistance in them, which is why they're kind of shaped like heat sinks and they're bolted to the chassis. These did get hot in operation. Modern silicon diodes are much more efficient, so if you just go with 2 straight diodes to replace these, you're going to be putting a little bit more voltage than these sets were designed for. But in practice, from other people I've heard from that have done that, and my own personal experience, the sets can handle it. But it certainly wouldn't hurt to throw around a 47 ohm series resistor in with both diodes. Just keep in mind those resistors are going to get a little bit warm, so mount them appropriately. By way of comparison, I pulled out a comparable, well, not a comparable, a contemporary TV from Admiral, which uses electromagnetic deflection. And look at how much larger it is, and there are considerably more parts in this set. It also weighs easily 4 times as much as this chassis. Now, to be fair, part of that is the weight of the CRT, but another big factor is power transformer and just a whole lot more steel. Larger chassis, more robust chassis, heavier gauge steel. Big high voltage cage here. This is aluminum. It's a little lightweight aluminum box. There's a big steel box here to generate the high voltage on this set. Electromagnetic deflection, so you got some big coils in here, lots of iron, lots of copper. Nothing like that on this set. Well, that's how they were able to save costs. No power transformer. No, none of this stuff. No electromagnetic focus coil. No deflection yoke. Not really a flyback, which is what's inside here. Flyback and a big horizontal output tube and high voltage rectifier. What this has instead is what's in this little box, which I will now show you. I went around and removed all those 1/4" sheet metal screws and the nut that was on top here, so I can now reveal what's inside. We have a high voltage rectifier, a 1B3, and a coil. Strictly speaking, this is not a flyback. This is a flyback. I believe it's so named because it doesn't just generate high voltage, it also powers the horizontal yoke to make the beam fly back across the CRT. This has nothing to do with the horizontal deflection in this set. This strictly generates the 6,000 volts. To do that, they've got a 25L6 tube here, which drives the primary, which is this donut coil down here. And then there's a zillion turns of wire here, 2 stack coils. So it's a huge step-up transformer, like 1,000-to-1 ratio or whatever it might be. There's also 1 loop of wire around here, which goes to the filament on this tube. So this pumps a lot of voltage and current through the primary coil, and then there's 1 secondary coil to power the filament on the rectifier, and the other secondary gets rectified by this tube. And then this little goofy spring thing here you want to be very careful with. It's actually a tickler coil for the oscillator. This provides some feedback to keep the oscillations going. This one's actually glued in place, so I really don't want to mess with this. On other sets I've had these in various conditions. One was even broken off. If you have to replace this tube or readjust this coil, the service manual says to put it like 1/3 of the way up from the base. And ideally you want to have a high voltage probe and you want to monitor the high voltage, and you can slide this coil up and down until you get 6,000 volts. But another way you can do it is take the cover off and keep yourself way away from the high voltage and all that, and do this in subdued lighting and look at the filament glow on the 1B3 tube and adjust this coil so you get a nice bright filament. If it's too dim, that means you're not getting enough power going through here. You want to be very careful with all this stuff. Replacements are hard to find, and it's fairly delicate stuff, so keep the cover on at all times. Oh, something else interesting about this Although this set runs right off the AC line, this chassis is not hot. It just floats. It's kind of like an earth potential. And if you notice, this aluminum tray here is actually insulated from the chassis. And I believe that this cover and the base here is actually a circuit ground, isolated from the chassis, which is earth ground. So just something to keep in mind when you're measuring voltages, that this is not at the same potential as this. Do not connect these two together. When you're using your meter, do not clip the negative lead onto the chassis. You have to find an actual negative bus down below, which is running throughout the set. Just with all the various wires down there. Now, as far as the tubes go, generally should be fairly easy to find. 6AG5. Some of the sets also use 6AU6s in here. Some use 6AG5s. Either way, 6AU6s and 6AG5s are very common TV tubes. 12AT7 shouldn't be too bad. They're more common, or less valuable, I should say, than the 12AU7 and 12AX7s that the audiophiles gobble up. Two 25L6s, one to power the high voltage and one for audio. Generally not too hard to find. And then there are, I think, three 12SN7s. Those can be a little tricky to find. 6SN7s and 12SN7s are commonly used in guitar amps and other audio gear, so you're going to have to fight the audio crowd to get some of those. 6AL5 shouldn't be too much trouble. And then there's the 6SL7. I found that to be the most difficult tube to find when I started working on these, again because of the audio crowd. So hard, in fact, I ended up buying a bunch of tubes that are actually 6H9Cs, and these came from Bulgaria. These are actually Soviet tubes. Cheap for sure, and they did get here eventually, but I gotta tell you, they don't work so well. Some of them actually would short out because there is a fairly high voltage in the circuit on this. This is for the vertical deflection, I think, and there would be some arcing inside the actual elements inside the tube base. And when I finally got a really good Hickok tube tester and tested these out, they tested out pretty crappy. So as a last resort, they're okay, but I'd say buy a few of them because you may have to swap out a few until you find a good one. But hunt around, ask around, try to get a real American, like a vintage RCA 6SL7. It's worth it. Which leaves the ballast tube. I'm going to go into my office and pull out a blown up schematic and talk about that a bit more in detail. Alright, now for one of the most often discussed topics when it comes to these sets, and that is the ballast tube. It's all fine and well to use a voltage doubler right off the AC line to make the B+ and the B++ supply, but you've also got to power the tube filaments. Ideally, you would use enough tubes so you can string all the filaments together in series and get about 120 volts. For example, if your set used 10 12SN7s, put them in series, 12 times 10, 120 volts, put them right across the AC line, they'd be nice and happy, no problems. However, this set uses I think 15 or 16 tubes, and they do not add up to 120. And to complicate matters, they don't all use the same current, so you can't put them all in series. In particular, the pitcher tube uses 600 milliamps, and all the other tubes use 300 milliamps. So what they did is they introduced the ballast tube. As near as I can make out, this is what the originals look like. They were made by JFD, but they do have the Motorola logo on them. And this is that 303 type, 17A470303. This one is bad, as near as I can remember. This is the one that came in that really early TS4 set that I have, and I really hope it's still good. But I'm not going to hold out much hope for that, because I did have another set that had a good one. Within a few hours of playing, one of the elements burned out. What's inside these is like a toaster. It's got some resistive wire, probably nichrome wire, strung across some mica sheets. And all it does is get really hot and radiate excess voltage and current as heat. They serve no other purpose other than to get hot. And because they're exposed to air, they quite often burn out. So you've got to replace them with something. You have to have these in the set. You can't just bypass them with a dead short piece of wire. The tubes will blow out. So first thing that comes to mind is resistors, and that's what a lot of restorers have used. So for example, I've blown up the section of the schematic pertinent to the ballast and the tube filaments. Here is the base diagram for the 303 ballast. It has 1, 2, 3, 4, 5 elements, A, B, C, D, E. However, this element between 6 and 8, E, is not used on any but the very, very earliest of sets. The others just use, let's see, A, B, C, and D. And they label them on here, 105, 105, 37, 200. That's the resistance in ohms. So a lot of restorers out there, they use something like a 100 ohm, 100 ohm, 33, 39 ohm, and maybe a 220 ohm. And it'll work. It'll work all right. Few shortcomings though. One, they still get really, really hot. So hot that I recall one guy found that he couldn't use regular solder because it would soften up, and he ended up crimping all of his connections. Also, they're fairly big. You're going to have a hard time stuffing 4 big old power resistors inside here, because these have to be, at least 2 or 3 of these have to be on the order of 20 to 30 watt resistors. So you might have to use a big circuit board and maybe put it on an octal base and cram it in there. But one thing you lose is there's no surge protection. Power resistors, their resistance doesn't really change with current or temperature, so when you first plug in the set, current just flows right through them. However, these seem to absorb some of that surge current, although it's been a bit debated about what kind of wire they actually used in these, and did they or did they not offer any sort of soft startup. There's one easy way around that, and that is to choose your tubes carefully. For example, you're going to have some 6AU6s in this set. And there's the version of the 6AU6 that has an A at the end. And these are specifically engineered to be used in series wired sets, because they engineered the filaments to have a soft startup, a controlled warm-up time, I believe they called it. So if you use 6AU6A, 6AG5As, and so on, you'll be in pretty good shape. Or, if you can, get your hands on one of these. These are Amperite glass ballast tubes. Now you can really see what's going on in there with all those resistive wire elements and the mica supports. These absolutely do offer surge protection. That's what they mean by automatic regulator on the box. I've got a video up, one of my very first videos I think, and I also have a video series on assembling a VT71 Blonde where I show these in operation. When you first turn on the set, these glow cherry red and none of the tube's filaments light up. And then gradually the tube filaments start to glow and this diminishes. So absolutely these do provide a very nice controlled soft startup for all the other tubes in the set. So if you get one, by all means use them. However, notice these tube numbers. None of these are 303s. I've never seen a glass amp write 303, although I do believe they exist. Just very hard to come by. And almost every variation of the TS4 uses the 303. But, as I mentioned, the E segment is not used. And these 459s do not have the E, but you don't need it. But you do have to make one change. You need to move the wire that goes to pin 5 over to pin 6. I'll show you that in a moment on my computer screen. If you go to the good old antique radio forums and find the topic on need help on this 7-inch Motorola, you will find an in-depth discussion on these ballast tubes, including my 2 cents about the basing diagrams. So up top is the 303 we were just looking at. It has A, B, C, D, E. This is the 459. There's no E. And instead of that common tie point for 3 of these being on pin 5, it's on pin 6. So for example, on my TS4H set, all I had to do was take the wire going from pin 5, put it on pin 6. That let me use a 459. That was all I had to do. Done. But in spite of these being nice and offering that nice regulation, soft warm up, and these really never burn out because they have a hydrogen gas inside which protects the wire from corroding, they still get friggin' hot. So you still need that asbestos, they still got a ton of heat. So there is another option, which is to use either a diode in series with a resistor, or use a capacitor. If you recall, I did that a long time ago for one of my Philco radios. I'm going to pull up the calculator now and show you how you can use it. But before we can use that calculator, we have to do a little bit of figuring here. We need to figure out how much voltage we're dropping across the tubes. And this will vary from set to set. This is one thing I really don't like about this 303 ballast. It's very misleading. It may have been correct for the very early sets, but by the time you get to the TS4J, it is just flat out not right. They show 105 ohms, 105 ohms. But when you add up these tube voltages, these two strings are not equal. We should not have equal resistances on both these legs. So I'm going to go through now and add all these up. See these symbols here? Each one of these is one of the tubes, and that little triangle there, that's the tube filaments. So we got one there, one there, one there, and they go down, down, down. And this one loops around, it comes back up here. And notice they come together here and then jog over, and then there's one sitting down here, V15, I think that is. Now, what's that all about? Why do these two chains go down, come together, and then go over to this tube? Well, if you recall, I mentioned that all these tubes draw 300 milliamps, but this takes 600. So what they did is, you got your AC line comes in, goes through the ballast, and then goes through 2 series strings of tubes. They connect together and then go through, both go through one tube. So you've got 2 circuits of 300 milliamps that come together, and then there's 600 milliamps through the CRT. So it's another reason why you really want to control the startup surge, is because all the tubes go through the CRT. If you get one of these filaments draws too much current on startup for whatever reason, it's going to go through the CRT. So I'm going to get out the tube chart, figure out what's V13 and what's V8 and what's V10, and write down all these voltages and let's add them up, and then use a little bit of Ohm's law and assume a 120 volt input and see what these resistor values should actually be. Okay, I went through and looked up all of these tube filament values. Made a silly mistake at first. I put down 6 and 12, but really it should be 6.3 and 12.6. If you add all this up, you get one string of 75.4 volts AC and one of 81.7 volts AC, both at 300 milliamps. If you assume 120 volts AC in, do a little bit of Ohm's law, you end up with about 150 ohms and 128 ohms, both at a little under 15 watts. So I would go with at least 15, maybe 20 watts if you just want to use a straight up power resistor. Then you still have the 37 and the 200. I'm sorry, but I do not know the exact wattages on that. I'm not sure how much current flows through here, but I would imagine 10, 15, maybe 20 watts for sure you'd be safe on these. And I would imagine this one would be a bit higher wattage than this, because power is current squared times R, so same current pretty much flowing through both of these resistors, but this one is almost 10 times as large as this, so it's going to dissipate more heat. But there is another option. There's this great calculator I found online a while ago when I was doing a Philco radio that was also transformerless. What you do is you plug in your supply voltage and your frequency and your heater voltage and your heater current and the surge limiter drop, which I'll explain later, and it will show you what your power resistor would be. That's where I got that value of 150 ohms. I rounded it up from 149 and around about 15 watts. But you got a couple other options. Instead of just using a power resistor, you can use a power resistor in series with a diode. The diode will rectify the AC and cut out about half of it, which dissipates a lot of that power without really radiating any heat. I mean, it just clips the voltage and current out of it entirely. So then you only need to use a 32 ohm and 2.8 watt resistor in series with a diode. Or you can use a dropper capacitor. And that's where that surge drop comes in. So you can use basically a 10 microfarad AC capacitor in series with a 33 ohm 3 watt resistor. That's really not saving you much from the diode. And that's because you really want to use a resistor in series with this to provide some surge protection. If I was to drop this surge limit down to 0, you see that drops to 8.5 microfarads, and then you have 0 power dissipation. Fantastic. But you're going to get a bit of surge current in there, so I'm not sure how well that would work. I'd be a little leery of trying that out, because you do not want to blow out these tube filaments, especially the picture tube. Recently a new old stock 7 JP4 sold on eBay for about 150 bucks. So by all means, protect that picture tube. At any rate, I put all three of these down on paper here. So straight up power resistors, 150 ohms and 128 ohms. Or resistor and diode, 32 ohms, diode, 11 ohms and a diode. Or basically both 33 ohms and 10 microfarad volt AC non-polarized caps at 10 microfarad and probably 250 volt AC is a pretty common value. I have not tried these two myself in a VT71. I have used them in radios and they work out really, really well. Actually, no, that's not true. I did use this in my Admiral T102. I forgot about that little portable set. I used this to replace like a 40 watt or 30 watt power resistor, and it worked out really well. So, I mean, there's your choices. Hunt down a ballast tube and deal with the asbestos and all the heat produced. Go with power resistors, get essentially the same amount of heat produced. Or go with a diode or a capacitor, and you will cut down that power dissipation considerably. However, in all these cases you will have this power being dissipated. You really can't eliminate this. Alright, I am going to cut off this video now because it's getting late. I will pick up in the next segment with trying to fabricate a mask for that suitcase set, and then I'll actually power up one of these sets and show you guys how they work.